Thank you, Prashant. Thank you for a warm introduction, and it's a pleasure to be here. And I will say that the discussion which happened, I think, was really exciting, and the points that you all brought about are so pertinent to the industry. And I think Mr. Pritesh brought about a point about the guy coming and asking you why am I in the shop floor. So just to share my anecdote, I come from a training background, and when I say training, I have been trained by my previous organization as a graduate trainee. And I really understand the points you have brought in terms of understanding the groundwork of working on the shop floor, and then you can come up. So I think the discussion was really pertinent, and very happy to be a part of the discussion. Having said that, I have a short presentation to make about the products that we have for the petrochemical and the specialty chemical industry. If you can have the presentation, please. I will also take cue from the discussion on collaboration. From the industry perspective, we also are working on some collaborations within the industry. So let me try to also take that cue. So this is the topic which I have decided to talk about a bit more. Next slide, please. Okay, I have it. Yeah. So this is what I had decided to present to you. So I'll just quickly cover the company introduction. I come from a material background, so a little bit on corrosion and material selection. Then we have a case study on one of the materials that we have deployed for metal dusting corrosion. We'll just go through that a bit. I'll also try to cover the portfolio that we have at Tubacex for different materials. And then lastly, we'll try to conclude with a couple of pointers on what is happening in the industry. This is what we are. So we are a world leader in advanced industrial solutions for energy and mobility. What this means is that wherever we have the demanding environments coming in terms of high pressure, low pressure, high temperature, high corrosion, we come in. So we are a company that provides tubular solutions and in different kind of alloys. This is what we are trying to achieve. As Tubacex, historically, we have been a manufacturer where we have produced materials based on what the customer demands are. But we understand the needs of the current market conditions, and we have to innovate. So we are trying to work on the backward integration as well as the forward integration in terms of our solutions, where we get engaged with our customers, the licensors, also with academia to understand what kind of products we can innovate and give to the industry. And we also work on the forward integration part, where we are getting more and more involved with our customers to provide them services. This is what we are as a company. We are a global leader, and we have 25 production plants, one in India as well. We have 2 service centers and, of course, 2 innovation centers and 17 service centers. And this pie is extremely important for us because more than 40% of our products are serviced in Asia and Middle East, which is a very important end-use market for us. And that's where we come in with this new way of working, where we are more close to our customers. I will skip this part, but this only talks about our journey for the last couple of years. And we have a new strategy that we have introduced, which in a way pertains back to what I mentioned earlier about being more close to our customers. This is what is our company portfolio. So we have a complete portfolio of steel, pipes, tubes, and pipe fittings, where we offer solutions from various plants of us globally. This is one slide of us that gives a complete idea about our portfolio and different plants. And our product are coming in 5 baskets, the main product line being pipes and tubes. This is one slide which I will take a little bit more time on. So if you remember the earlier slide, I spoke about the backward and the forward integration part in terms of innovating. These are some examples that we are proud to display, which has happened in the last couple of years. So with our customers and licensors, which here are Casale and Saipem, we have innovated alloys. So depending upon what the needs they have seen, we have worked together with them to develop alloys and then make it an industry standard. We also have worked with supply partners. So the 2 companies you can see here, VDM Metals and Special Metals, these are actually competitors of ours, but we have collaborated to ensure that the entire ecosystem has been served by us. So the customers from our side need the entire portfolio of pipes, tubes, plates, flats, all those kind of products. These companies, and even we have limitations. But with these solutions, it's a complete ecosystem that can come to you, and then you can basically have the complete alloy solution in front of you. These are our sectors that we are working on. We are from the entire, I'll say all the streams that we cover, starting from the upstream, midstream, downstream. We are also into thermal and nuclear. India has been a very important market for us. We have been delivering for the coal-fired power plant for the last 50 years, and we continue to do so. Of course, we are also into aerospace and defense. Our tubes are a part of the most famous LEAP engine. We deliver that from our plant in US. And then, of course, we are also very active on the low carbon side, where we are, I will say, involved in more research activities with academia and trying to understand the needs of the market, one being hydrogen. Now I will come into the bit on what I had thought about for this session. I think everyone talks about stainless steel, but just a bit of history from where it is coming from. So, as any invention, even stainless steel was invented by accident. The gentleman you see on the photographs is the one who invented stainless steel. And this time he was basically, or let's say in the 1915 era, they were innovating on steels for gun barrels. World War I era. So that was the time they wanted different steels for gun barrels, and he was innovating on that, I will say, project. And when you basically do a microsection of the steel, you need to etch the steel. And when he etched the steel with minimum 14% chromium, he found that those samples were bright and they didn't corrode. That's when the first paper was introduced, which is called the non-rusting steel. You can see on the right, which was in the New York Times. So from non-rusting steel to the current terminology of stainless steel. So what is stainless steel? It's a alloy which has minimum 12% chromium. And this chromium is what provides the oxide layer that is preventing your steel from corroding. The beauty of stainless steel is that this layer is reappearing. So that is where the term repassivation comes in. So this repassivates, and that's how you get the steel which is going to be rust-free or stainless. However, the time gap between the passivation layer to reappear is the time where corrosion happens. And with different alloy solutions, we are trying to delay that formation. So in the next slides, you will understand that we will not eliminate corrosion. Corrosion is bound to happen. It's a natural phenomenon. But with different alloys, we are going to delay that formation. As I told you, stainless steel is an alloy, and these are the alloying elements that come in. So we have a host of them, but of course, chromium is one of the most important alloying elements. And the more and more we are seeing the nickel-based materials coming in, that's where nickel is getting more and more prominent, and that's also what helps in giving additional properties. I'll be happy to share more information, but then in interest of time, I'll just limit the speech to the content which I thought about. The elements are extremely important. However, it's also important on the percentage of alloying elements coming in, and also how we are utilizing these elements for production. So it is not that we add the best possible percentage and you get the best steel. No, a balance is what is extremely important. So as I told you, corrosion is a natural process. It's bound to happen, and this is the cycle that it follows. So end of the day, no one can claim that we can have a corrosion-free product or a corrosion-free steel. This is bound to happen, and we're just delaying this process as far as possible. So when we talk about material selection, we factor these three main aspects from an industry perspective, also from an equipment perspective. So corrosion is the most important aspect that decides what material can be used. Then comes the type of corrosion. There are different kinds in the industry, and depending upon what problem you're facing, we can have steels based on that. And lastly, the most important and pertinent topic these days is the cost versus life. One of the questions that customers come to us asking is, do we really have to go for an upgrade in metallurgy? Is it required? Many times it's not. But then this discussion is what is important to understand. Is it really required as a change, or you need to go for some other kind of upgrade? So these are the three main aspects that we try to work upon when we are talking about materials. And of course, end of the day, we are a material supplier. We cannot guarantee those properties. It has to eventually come from a designer or a licensor who will, let's say, have a rubber stamp on top of what information we have provided. Corrosions are in various forms. So we have the two bases. One is the wet corrosion, other one is the high temperature corrosion. Depending upon the temperature conditions, these are defined. Of course, this is more of an industry knowledge, but then these are the main ones that we find. And in the current times, what we are seeing is a transition between the high temperature phase to the low temperature phase. So we need to have steels that can be versatile. So if I talk about the current challenges that the petrochemical and the specialty chemical industry is facing in terms of various materials, we have real severe conditions of corrosion coming in. That is, of course, because of the various exposure to chlorides, hydrogen sulfides, aggressive acids, and all these are making the situation difficult in terms of materials. We have the variable and the lower quality feedstocks. The feedstocks are getting more and more sour. You are having unconventional ways of crude coming in. That also is in a way preempting the challenges in the industry. Temperatures, we are going higher and higher. We need to process more volumes. So that also is not something which material likes, but then we need to have something which we can work on. The environmental standards, the panel one spoke a lot on the safety and the environmental standards. This also is preempting a lot of things towards cleaner operations, low emissions, that eventually will go back to materials. Focus on operational cost and efficiencies. This again is a discussion that we are seeing a lot happening in the last couple of years, and this goes back to what kind of material can do that. And of course, material selection aspect is where we come in, and then we try to provide the best possible solution. So there are different kinds of alloys that we can recommend. I have just made a list of all kinds of alloys that we are seeing in the industry, and this we can elaborate, but the main common alloys that we see in the chemical and the specialty chemical industry is alloys like 600, 601, Hastelloy, 276, or C22. But this chart I have made here so that it could be a guide for you when you're deciding your equipment change. It could be a guide for you to also understand what material suits the best. Now, I would want to share a small case study on a new alloy that we have introduced along with VDM Metals of Germany. And this is for low carbon hydrogen production and for use in the petrochemical industry. So we are trying to fight a menace in this industry which is called metal dusting. It's an extreme form of carburization corrosion where we have a gas phase and we have potentially carburizing environment coming in from oxygen, carbon monoxide, water also comes in, and we are transiting in the temperature between 800 degrees to 400 degrees. So that is when this phenomenon happens, and basically you have a dust that is formed on the surface of the metal. It could be a tube, it could be a plate, and it comes out in form of a powder. That's why the name metal dusting. Different alloys are there in the industry for this. I have listed some of them, starting with the basic 800 and then going on to the newer alloys that we have introduced. However, this remains a problem. So the need in the industry is to have solutions that can take care of this effect. And one of the main challenges in metal dusting is that it is a catastrophic effect, which means that it can happen within hours and within minutes as well. So if the steel reaches that zone, it can just fail and you can have a catastrophe there. So this is where we introduced this alloy called as 699XA. It has a very high metal dusting resistance. It can withstand high creep resistance. It is also having good workable properties, which means that we can have different forms of material that we can process. And it has all the required international standard requirements, and we have processed various kind of dimensions in this material as well. Some data with corrosion. The graph is not very clear, at least from here, but the last chart that you see is the one for 699XA, and it outperforms the other alloys. And we have seen the first pit formation happening after more than 5,000 hours. So it means that it has a very good corrosion against metal dusting, and we are able to withstand the needs of the market. To summarize this case study, of course, this alloy has been one of the benchmarks in terms of metal dusting resistance. And we have a couple of alloys, a couple of references that we have seen in the industry, global references. In fact, a couple of them in India as well. So we have Nair, who in their hydrogen manufacturing unit went with this alloy. And then we have RCF, and also we have one in Indonesia as well. And there are a couple of other cases that we are working on with the new technologies where they are under NDA. With this, I come to the part where I want to be a little bit more specific into what we are getting into. So what we are supplying here are tubes that are going into the heat exchange applications in various process plants and petrochemical and specialty chemical plants. As a company, we have 5 plants globally to produce this portfolio. Our plants in Austria, we have a plant in India, 2 in US, and 1 in Spain. The plant in India is what is the focus for the Asia market, and that's what we are trying to promote in a way so that end customers can have access to. This is a bit information about what we can process in terms of size capabilities, lengths, which again is very important when a designer utilizes information for his calculations. And then these are the list of alloys that every plant can offer. And we are very proud of this slide in a way that we have localized majority of our offerings that we were, let's say, offering in the past from our global plants. So the stars that you see here are the ones which are ready to offer to the market, and the ones in pink are under industrialization. So if I come to the grades which are used in the industry, which are the high nickel based materials, you can see a host of them that are already localized, and we are ready with the solutions which are used in various equipments in the petrochemical and specialty chemical plants in India. This is the product capability of this plant. We have 4 product lines here. We have heat exchanger tubing. We have the product line that we moved from Spain to India, which is boilers and fire heaters. Instrumentation tubing is one of our main product lines. Next time you get into a MGL gas station, you will find our tubes around. We are having a 40% market share in that segment. You enter the gas station, you will find tubes inside the dispenser, behind in the casket, compressor. All these tubes are produced in India by us and delivered to various set of customers. And then lastly, we have the flow pipes which are used for various applications. We are also very happy with the localization journey that we took with this plant when we acquired it in 2015. And all these products that you see listed here have been shifted from our plants in Europe, US to India. So we have, for example, the one which I shared, the city gas distribution. This is a market that we started activities way back in 2018. And every tube that is delivered to this market now is 100% localized. We also collaborated with BHEL, where we localized certain grades in India. We were the first to do that, and that's where we also were awarded by BHEL in one of their Samvad events. We are now moving ahead with the next generation of boilers, where they will go for advanced materials, and that also will be localized. And lastly, we also have localized a host of nickel-based materials used in this industry, which we are ready to offer from our plant in India. So this is what we have done. We have, again, a collaborative approach here. So at Tubacex, we believe that if we can't produce these alloys, we work with the giants in the market so that we can together come and offer our solutions. So the grades which are commonly used in this sector are the grades listed above: alloy 600, 601, Monal 400, C22, C276, and nickel 200. Depending upon the application, it could be a fluoride-based, halides grade, it could also be caustic. We have a chart for deciding what. So in this, we have partnered with a company of UK called Special Metals. They have been one of the most active players in this sector. We are getting the pre-material from them, and the final cold forming will be done at our plant in India. So with this, two global giants are coming together, collaborating, so that you have the best solution available with you. And this is my last slide. Why are we doing this? The need for higher alloys. The industry, there is a demand for these high alloys, and that's the reason why we are coming with these solutions. We are working on solutions along with licensors and end users, which is an industry new for our segment. So we have a couple of examples with global giants. We have a complete portfolio now, along with localization. So when a customer wants steel in different forms, we have that in partnership with other companies. And then when there's localization required, we also are working with, for example, with Special Metals here to ensure that you have the best quality material available locally in India. And this fits in line with the Vikasit Bharat and the Atmanirbhar program of the Government of India, where we have our plant in Gujarat, in Umargaon, and we are ready to support the Indian chemical and specialty chemical industry with our solutions which are presented towards advanced metallurgy and also ensuring global partnerships. Thank you. Thank you for your time.